Hello everyone, these are this is the video solutions for Can You Do 6. This is the topic that will be assessed on quiz 6. So our first problem is asking us to take a set of data and by hand find the 5-number summary, calculate if there are outliers, and then plot the data as a box plot. So I'll zoom out a little bit so you can see the bulk of my work. Here is my box plot. I have labeled it very specifically. I have labeled it as student scores on Miss Lau's statistics test. But what I have boxed here, just student scores, is enough. You have to label, and labeling as student scores is acceptable. I just was very specific when I labeled this. I have 2 outliers, one at 43 and 45. I think that the distribution looks roughly symmetric if you don't consider these outliers. So that's our box plot. And the follow-up question for our box plot is, how did the students do on Miss Lau's first test? One of the most important things you're always going to want to look at on any box plot is the median. Remember, the median tells you the typical observation, and if the box plot is symmetric, it tells you, or it gives you a rough estimate for what your mean is. So I know that because this box plot is roughly symmetric, my median and my mean are going to be about the same. So that means on average, students scored around 88 on Miss Lau's test. So I know that the average is going to be close to 88 because the median is 88 and this is symmetric. So my response is Miss Lau's students did well on the first test. Students typically scored about 88 on the test, and 75% of Miss Lau's students scored at least 82. So let's talk about how I know that at least 75% scored at least 82. Well, I looked at quartile 1. To the right of quartile 1 is 75% of the data. So that means 75% of the kids got at least an 82. 50% of the kids got an 88 or higher. So overall, I think that Miss Lau's students did very well on the test. I think that it is very important that you understand this last statement that I made. 75% of Miss Lau's students scored at least an 82 because 75% of your box plot is to the right of 82. Okay, number 2. We get a group of 78 third grade students in a Midwestern elementary school. They took a self-concept test that measured how well they feel about themselves. Higher scores indicate more positive self-concepts, and the lowest self-concept scores were 20, 26, 27, 31, and 32. They give us summary statistics and a histogram. Are there any outliers? Justify your answer. So I am getting yes. The lower bound is a score of 27.5, less than 27.5. So I know from my scores right here that 27, 26, and 20 are outliers then. Anything less than 27.5 is going to be an outlier on the lower end. And luckily they told me up here the lowest self-concept scores. So now I know these 3, 27, 26, and 20 are outliers. The upper bound is 87.5. They didn't give me any information on the highest scores, but I can look at this maximum over here, and this maximum tells me that I didn't have any self-concept scores that were above 84. So I do not have any outliers on the upper end. So that is part A. Are there any outliers? Yes, there are 3 on the lower end, none on the upper end. Draw a box plot of this distribution. So we have to replace this minimum for our box plot with 31. These 3 are now outliers, so what we use as our minimum for our box plot is the 31. This problem would have been much more difficult. I'm not even sure if we would have been able to do it without them giving us that information. So down here I have listed that my min is 31, quartile 1 is 50, and I'm just pulling this for the summary from the summary statistics. Median 59, quartile 3, 65. Okay, that's an Amber Alert on my phone. Sorry about that, family. Quartile 3 is 65 and the max is 84. So I build my x-axis off of that. I should have spaced this out a little bit better, but you know, that's life. I labeled my x-axis self-concept scores, went from 20 to 85, scaled by 5s, and this is what my box plot looks like. Thinking he's skewed to the left. Definitely thinking he's skewed to the left, which the histogram totally shows. The mean is 56 and the median is 59, so it is a little bit skewed to the left. Your mean is less than your median. One of the students had a self-concept score of 32. If this score had been accidentally recorded as 22, what effect would this have had on the value of the mean and the median? This is a question that you will definitely be asked on your exam. This is a question that you will definitely be asked on your exam. This is a question that will definitely be asked on a retake exam. This is a question that will definitely be asked on a retake quiz. This is one of the most important concepts from Unit 1. So let's revisit what it was. If the self-concept score of 32 was accidentally recorded as a lower score of 22, what would this effect have on the mean and the median? So first, I know the median would not change. The median is the middle value, and the middle value won't change because the mistake doesn't affect the number of observations. Your observations stay at 22, so the median is in the same position, and the number that you misrecorded wasn't anywhere near the middle. It was on the lower end. So your median will not be affected at all. Your mean, however, will be lower or decrease. And the reason why is because when you add up all of your observations to calculate the mean, it'll be smaller than it should be. So if you accidentally put a number that is smaller than it should be, then the sum of all the observations is smaller than it should be, which means your average is going to be smaller than it would be. So median stays the same, the mean will decrease. Question 3. A team of psychologists studied the concept of visualization in basketball. Essentially what they did was they split players into 2 groups. One group visualized making their shots before they attempted, and another group did not. They had to shoot until they made 2 in a row. And what we were interested in was, would they do better if they visualized first? So this is the number of attempts that you're seeing in the box plot. And in this case, a lower number is better. So for instance, it looks like the minimum in both box plots was 2. So that means that there were players that made the first 2 and then they were done. This median of 4 means that there were players that had to shoot 4 shots. So they shot 2 and missed and then got 2 in a row. So this is telling you how many times they had to shoot before they were done. And they were done once they made 2 in a row. Based on the box plots, did the basketball players who received visualization training tend to need fewer attempts? Explain your reasoning. So, just like I said on our first question, one of the most important things you can look at in a box plot is the center. The center tells you the typical observation. So what that means is the players that received visualization typically needed 4 shots. The players that did not receive visualization typically needed 7 shots. So visualization needed more attempts than the kids who had visualization. I think I said that backward. Let me say that one more time. No visualization needed more attempts than the kids who received visualization training. So I have answered very thoroughly. If you're pressed for time, I'm sure that you do not have to repeat this statement. Yes, the box plots show that players who received visualization training tend to need fewer attempts to make 2 consecutive baskets from a distance of 22 feet. The median for those who received visualization was 4, but the median for those who did not was 7. Players that did not receive visualization typically need more attempts. So what you want to make sure that you have is what I am highlighting in green. You want to say yes. Make sure that you say yes somewhere. This part where you say yes is very important, but you could have said yes, the median for those who receive blah, blah, blah. This is just basically copying down the prompt word for word, which does make you sound like you know what you're doing, but also takes time. Okay, number 4, the following is a box plot of the birth weight in ounces of a sample of 160 infants born in a local hospital. About 40 of the birth weights were below. Okay, so the first thing that we need to do, because they tell us how many infants we looked at, was figure out what percent is 40 of 160. So 40 of 160 is 25%. So what we really want to find is the first quartile. About 25% of the birth weights were below. So instead of saying about 40 of the birth rates were below, we can now say about 25% of the birth rates were below. Well, the first quartile, sorry, I don't know why I have that marked. The first quartile is this right here. So if I drag that down, if I drag the first quartile down, what I am seeing is that it's just over 100. So I'm saying that it is B. It is 102 ounces. 92 ounces, 92 ounces is only like 12% of the data, because this is 25%. So it's not A. 112 ounces, it's not that, because that's more than the median. So that would be more like 50%. 122 ounces is quartile 3, so that means 75% of the infants weighed less than 122 ounces, and 132 ounces is the max. 100% of the infants weighed less than 132 ounces. So the trick here was to convert the number of babies to a percent, and then ask yourself, what weight had 25% of the data below it? So hopefully that helps you on that one. Question 4 is a doozy. So question 4 is what your test, your quiz is going to be on. And if you watch the comparing box plots video, you know that you did not have to find any specific values besides the medians. The reason why is because these are decimals and it's just too time consuming, and you have to make too many estimates for it to be worthwhile for you to actually go through and calculate the min and the max on all of these. You can see that I have the shape labeled. Top is right skewed, bottom is left skewed, and those should be pretty obvious. I was really torn on the middle one. So I ended up trying to estimate the max and the min. I got that the minimum somewhere around 3.1 and the max is somewhere around 6.5. And once I compared those distances, I felt like they were close enough to say that this is roughly symmetric. Maybe you eyeballed it and felt good that it was roughly symmetric, but this was one that I was like, I'm not sure, and wanted to look at. Okay, so you're really going to want to use this as your framework or like a good example of how you want to compare box plots. The only thing that would make my response better is if I had specific values. So first I address shape. Each distribution of Aldrin concentration is shaped differently. And notice I'm being very specific. Each distribution of Aldrin concentration, you don't just want to say they're all shaped differently. Be specific. Each distribution of whatever the problem is giving you is, and then continue. The shape for river X is right skewed, for river Y is approximately symmetric, and for river Z is left skewed. So I have chunked this on the side as my shape response. The concentration of Aldrin tends to be the highest in river X because the median is 5.2, and lowest in river Z because the median is 4.3. I'm not even going to say that river Y is in the middle because that should be obvious. The best part of my response is what I have here highlighted. About half of the samples taken from river X and Y had more Aldrin than all of the samples taken from river Z. Let me show you how I knew this. If I come up and look at the max value of Aldrin in river Z, I'm noticing that that's lining up very closely with the median on river Y. And it is also very close to the median for river X. And we know that from the median, there is 50% of your data. So what this is telling me, this space that I'm highlighting is telling me, is that 50% of the samples taken from river X had a higher concentration than all of the samples taken from river Z, and 50% of the samples taken from river Y had a higher concentration than any of the samples taken from river Z. So you're lining up your box plots and you're noticing that these line up pretty closely. It's not perfect, but pretty closely with the medians. So we can say about half of the samples taken from each of these rivers had more Aldrin than all of the samples taken from river Z. I know that that's kind of a complicated idea to catch, but it is very important when you are looking at box plots that you try to recognize things like that. So about half of the samples taken from the top two rivers had more Aldrin than all of the samples taken from river Z. Then lastly, I mentioned spread. The distribution for river X varies more than the other rivers in terms of range and IQR. Notice that I'm not giving it. I can just see this river has the longest box plot and the longest rectangle. So this is IQR, your box is IQR. The whole thing is range. Both the box and the whole thing are bigger for river Y and smallest for river Z. Smallest box and whisker. So the distribution for river X varies more than the other rivers in terms of range and IQR. River Z has the smallest range in IQR, and I'm not giving specific values because I'd have to estimate it. It'd be very cumbersome and not worthwhile. This shows that I know that this is more spread out than this, and this is the least spread out than all of them. Okay, so that is all for number 5. I'm not mentioning outliers because it really doesn't add anything to this problem. If you said none of the distributions have outliers, perfect. That's great. You would be fine. And if you didn't say it like I didn't, this isn't definitely enough to earn you full credit. So this is what you want to focus on, study, make sure you feel good about for your quiz. Number 6, we have the amount of time that people waited in a local store, and we split it out by gender. So I can see that the women tended to wait for a less amount of time than the men did, because all of the women are from 5 to 20. But the men go all the way from 5 to 45, and then we have some crazy pants out at 60 and 90. So just by looking at this, I can see that men tended to take more time or spent more time. Is this waiting? Spent more time in a local store. So now let's get into the meat of the problem and see what they're asking us about. The range in the amount of time in minutes males spend in the sample of customers is approximately 40 minutes. So the range for males is 40 minutes. Nope. If you're doing the range in terms of the min subtract the maximum and you include 90, your range is 85. If you don't include 90, you would start at 45 and minus 5, and that would give you 40. But I'm pretty sure that you need to include your outlier. So I'm thinking that A is no. B, the mean for males is approximately 20 minutes. The mean for males is 20 minutes. Well, the median for males is 20 minutes, but this distribution is definitely right skewed. The male distribution is definitely right skewed, which means that your median is 20 minutes, but your mean is going to be longer than 20 minutes because these outliers are going to pull your mean toward them. So B is a definite no. This distribution is right skewed because of these outliers, so the mean will be bigger than the median, and the median is 20. The third quartile of the amount of time in minutes males spend is, I think that I may have fixed this on yours. Let's hope that I have. Sorry, unprepared. Is 45 minutes. So the third quartile is 45 minutes. No, the third quartile for the males is like 29 minutes. This is quartile 3, so that's 29 minutes. So it's definitely not C. It is definitely not C. The interquartile range of the amount of time in minutes females spend is 15. Okay, well, let's figure out. Our quartile 1 is, honestly, it looks like 8, 7.5 or 8. My quartile 3 looks like 17 or 18. So I'm getting a range of 9 or 10. Like you can see my work here. I originally thought it was 18 and 8. It might be 17 and 8, but either one, that's 9 or 10. So no, it's definitely not 15 minutes. And then E, approximately half of the males in the sample of customers spent at least as much time in the store as any or all of the any or all female in the sample of customers. I think that's supposed to say females. Yes. So if I highlight this like I did on the previous problem, you can see that the max amount of time that women spent is around 20 minutes. The max amount of time that women spent is 20 minutes. And 50% of the men spent 20 minutes or more. So approximately half of the males sampled spent at least as much time in the store as all the females that were sampled. Even on this lower end, like this female spent only 5 minutes in the store. Well, this dude spent at least 5 minutes. He actually spent 20 minutes. This Max here spent 45 minutes, so he definitely spent at least 5 minutes or 10 minutes or 15 minutes. So what they're trying to say is the most amount of time any female spent in the store was 20 minutes, and half of the males spent that and more. So they spent at least as much time as all the females. So it's E, which makes me feel better about A. I feel pretty confident we were supposed to include the outlier at 90. 7 is a really great problem. So the box plots above summarize 2 data sets, A and B. Which of the following must be true? Set A contains more data than set B. No. No, it does not. And by data, do they mean observations? And if they mean observations, we have discussed that we don't know how many observations are in a box plot unless they tell us. So first of all, I'm not even sure what they mean by data, but I'm pretty sure they mean observations. And unless they tell me, there's no way for me to know how many observations are in set A. 2, the box of set A contains more data than the box of set B. No. The spread is larger. The spread for the IQR is larger for set A than set B, but we don't know how much data is in each of the boxes. We know that it's 50% of set A and 50% of set B, but we don't know if it's more unless they give us the number of observations. So I already know it cannot be 1, it cannot be 2, because we cannot say anything about how many observations were included in a box plot. The last one, the data set or the data in set A have a larger range than the data in set B. Yes. The box and whisker is longer for set A than it is for set B, and the box is longer in set A than set B. So the range is your box and whisker. The range is, I'll just highlight it. This is what they mean by range. So this box and whisker is much longer than this box and whisker. So it is 3 only. 3 only. The biggest takeaway from this is that we do not know. the number of observations, unless the problem tells us. Okay, lovies, we're on the last page. This one I'm going to kind of do real time because I feel like, is very challenging, but it is going to be extremely helpful to go over it. It wants to know which of these box plots matches this histogram. Well, I can automatically exclude C. Why? Good. It has outliers. C is a no. It has an outlier on the lower end and upper end. The histogram is not showing me any outliers, at least the way that it's made. D and E are also a no. See if you can figure out why. So D is right skewed. E is left skewed. So it cannot be either of those because this data set is symmetric. If you folded it in half right there, it would line up exactly. So now all we have to do is decide how big the box is. Well, I can see it in my brain, but I don't really know any way to explain this to you besides to estimate how many observations are in each bin. Now, they don't tell us. There is no numbers here, so I'm just going to make up some numbers that make sense to me. So if I'm comparing these, to me, it looks like this would be 2 and this would be 3. I don't know that for sure, but I feel like those numbers are logical and they make sense. So what would the next bar be? Hopefully you're saying 4. I think the next bar is probably 6. And I think the last bar is 9. And I'm deciding that just based on how high the bars are and comparing them to the one next to it. This could be 90, 60, 40, 30, 20. But for what I'm doing, these numbers will work just fine. So if you add up all these numbers, you get that there are 48 observations. Well, how is this going to help us? Well, let's find the median. So the median is going to be here. Okay, well, the median looks like he's in between 5 and 6. So if I go down here, both A and B are in between 5 and 6. So that doesn't help. So the next thing that I'm going to check are the quartiles. Okay, well, there's 24 observations to the left of the median. If you add those up, that's 24, which means that quartile 1 is between the 12th and 13th observation. So that means quartile 1 is in this bin. Quartile 1 is in this bin. Well, because this is symmetric, that means that quartile 3 is in this bin. And now I can see which one I should choose. If you don't see it yet, I'm going to make a rough box plot on this histogram. This would be your minimum. This is your quartile 1. Median, quartile 3, maximum. I connect the whiskers. I make my box as best I can. And that box and whisker plot matches A the best. The whiskers are very small because this is 25% of the data, and 25% of the data is in the first two bins. But then the next 25% is spread out between three bins. So that's why these whiskers are really short, is because a bunch of the data is in the first two bins, and then the next 25% of data is in the next four bins, then the next four bins, and then two bins. So hopefully either finding the quartiles and matching it up or making a box plot on there that's similar is helpful. Maybe just visualizing it and knowing the whiskers are small because most of your data is clustered here, and then the middle 50% is spread out, and that's why the bars are so low. And then the last one is short or a small whisker because 25% of the data is mostly on these two bins. So hopefully the visual explanation will help some of you. I know that that's hard, and if not, hopefully the box plot helps some of you. And in the very least, I'm hoping that estimating the frequency in the bars and finding median and quartiles helps you to know the shape, because this is an important skill. And then lastly, we have multiple choice that is very similar to what your quiz question will be. So you've had three of these now. We compared the male and the females in our notes. For weight, we compared the male and female waiting time on the previous page, and now we are comparing the number of on-time arrivals. This is just one box plot this time. For your quiz, it will just be one box plot. So the quiz will be the most similar to this question probably. An airline recorded the number of on-time arrivals for a sample of 100 flights each day. The box plot below summarizes the data recorded for 1 year. So we're thinking that N is 365. And then on each day, they looked at 100 flights. So they did this 365 days, and each day looked at 100 flights. Okay, based on the box plot, which must be true? The range of the number of on-time arrivals is greater than 90. Okay, well, our minimum is 75, and our maximum, is that 75? 70, 72, 74, 76, 78. So this is going by twos. I apologize. Our minimum is 72. That means our maximum is 92, 94. So our range is 94 minus 72, or 22. So definitely not A. The interquartile range is 22. Okay, well, Q1 is 76 flights on time. Q3 is 80 flights on time. So IQR is 80 minus 76, which is 4. So definitely not B. The number of days that had at least 80 on-time arrivals is greater than the number of days that had at most 76 on-time arrivals. Holy moly. Okay, our first one is, what is the number of days that had at least 80 on-time arrivals? So at least 80 means it could be 80, 81, 82, 83, 84, all the way up to the max. So we have 80 is our third quartile. So that means at least 25% of the days, 25% of the days had at least 80 flights on time. Well, 25% of 365 is 91.25 days. Okay, the next one is the number of days that had at most 76. So at most means 76, 75, 74, 73. So 76 is quartile 1, and we want to know to the left. So that's 25% once again. And 25% of 365 is 91.25, so it is not C. The number of days that had at least 80 is exactly the same as the number of days that had at most 76. The reason why is because 76 is quartile 1. There's 25% of the data to the left, and 80 is quartile 3, so there's 25% of the data to the right. D, the number of days that had from 76 to 80 on-time arrivals is equal to the number of days that had at most 76 on-time arrivals. Okay, so we know at most was 91.25. Well, let's see how much data is between 76 and 80. Between 76 and 80 is 50% of the data. Between 76 and 80 is 50% of the data. 25 in this part of the box, 25 in this part of the box. So 50% of 365 is definitely going to be greater than 25% of 365. So that is 182. Okay, Famil, I am running out of time. I just ran out of storage space, and once I run out again, I cannot continue filming, so I'm going to go a little bit faster. I apologize. So on D, it cannot be D because we know that at most 76 on-time flights was 25%, and from 76 to 80 is 50%, so it can't be D. So it has to be E, but let's just verify. The difference between the median and the lower quartile for the number of on-time arrivals is less than 2. So the lower quartile is quartile 1. That is 76 on-time flights. The median is 77. The median is 77. So the distance between the two is 1. The distance between the two is 1. So, or the difference between the two is 1, so it is E. Like I said, your quiz question on this will be similar to this problem. You will have a comparing distributions problem that is very similar to the river problem. I will be ready to answer any questions that you have on box plots when I see you in class. So hopefully you are really watching these videos and getting some important feedback on how to do these things. Okay, I think that's it. Love you guys. I know that analyzing these box plots can be a challenge, so just make sure that you try every problem. Watch the solutions video if you're hearing this, obviously you are, and then anything you still don't understand, either email me or ask me in class. All right, love you, Mooey.